Vectors and directions of vectors, kind of an important topic in physics. So one way that we could talk about directions is it's a pretty good way, and it makes sense because it's kind of like the clock. Got the clock up there, right? So here's north, straight toward the front of the room is north, and there's south, and this is east, and this is west. What we could do is we could start north. So north is 0 degrees. And then just like the clock, we could start north and then go clockwise from there. 0 degrees, 90 degrees, 180 degrees is south, 270 degrees is west. Then you go from 270 to 360 to go back to north. But that would make too much sense. Because in math and physics, we like to complicate things. And rather than doing something that makes sense to us like that clock, although some of you can't read the clock and you know it, we're going to do something different. We're going to start the angles at east and then go counterclockwise from there. Check this out. So 0 degrees is like east, positive x-axis. 0 degrees, counterclockwise from there. North is 90 to 180, that's west. 180 to 270, that's south. And then 270 all the way around to 360 to where we started. That's how we're going to do it. In math class, what we're going to do is we're going to start you at 0 radians, because radians, they have physical significance. It's the arc length divided by the radius. It's a beautiful, beautiful number. Except we often don't use numbers. We just use fractions. Fractions of pi. It's related to circumference. Circumference is 2 pi r. So 2 pi r. You start here and you go clockwise from the 0, pi over 2, pi. It's his angle. It's the radians. So 30 degrees, that's 1/6 of pi, and then 1/4 of pi, and then half a pi, and then you keep on going with a whole bunch of fractions. And then you come over here, and your math teacher has never said it, but 270 degrees, 3/4 of the full circle, that's pi and a half. Or as they always say it, 3 pi over 2. That's what they always say, 3 pi over 2. But to be partly consistent with your math class, or you're not learning some completely different system, we use that exact same idea. We start at 0 degrees, counterclockwise from there. This is 90, this is 180, this is 270, and this is 360. The 90 could be north, or you could just change your orientation whenever you want to, because you, as the problem solver, you have the option to choose where to put the axes. You can take those axes and you can rotate them if you want to, like for inclined planes.
Anyway, let's take a look at some real measurements on the 0 to 360 scale. So I've drawn 3, and I measured that angle from the negative x-axis to be 17 degrees. And the next one, third quadrant, measured to be 55 degrees. Next one's a bit short, so I extend that line so I can measure it using my big protractor. And the angle from the x-axis turns out to be 37 degrees. Now let's translate that. Almost halfway around, almost 180 degrees, so it's 17 degrees short, actually 163 degrees. Next one, third quadrant, more than halfway around, so it's 180 plus 55 gives you 235 degrees. Now the last one, starting at that positive x, it's almost all the way around, almost 360 degrees, 37 degrees short of 360 gives you 323 degrees, or you can say negative 37, because moving clockwise would be a negative angle. Just remember, easiest and best way to define angles in this class, starting with positive x is the 0, counterclockwise from there, all the way around to 360 degrees. Or if you love radians and pi because they're real and they're not based on a fake 360 degree year, then use this system.